Hey everyone, so today we are going to work on taking text and encoding it in binary. ASCII, which is how this is pronounced, sounds weird, but we pronounce this ASCII, assigns each letter or printable character, for example, on your keyboard, takes each printable character and assigns it a decimal value, which is in turn assigned a binary value. And if it's a binary value, we can store it in a computer and do stuff with it. And so this is just to practice and experience this. This is something you will need to do on your exam. And we'll look at some other things as we go throughout the rest of this week. But let's take the letter all. Now, every letter on that chart, I really only need 7 bits to encode it, but we'll turn them into 8 bits by adding a 0 in the front. Now, when I take A, I have all. Capital A is 65, and each of these L's are 108. Now, these numbers are small enough that you probably don't need to do a whole lot of division. I think what we could do is we could probably work through like these numbers here, like 1, 2, 4, 8, 16, 32, 64. I don't need to go to 128 because the 128 is greater than 108. So I don't need to go any more than that. And then if I take a look at 65, the 65 for the A, that's a 64 and a 1. So the A would be encoded as 10000001, but that is only 7 bits, so we're going to add a 0 in front to turn it into 8 bits. Now, each L is a 108. So again, we'll do the same thing. I'm just going to use this chart. I know there's got to be a 64 in it. And then I know there's probably going to be a 32 in it. So that right together, that is 96. And to go from 96 to 108, I need to add a little bit more. I can add an 8 to it. So when I add an 8 to it, that is going to become 104. And then if I add a 4 to it, that's going to give me the 108, and everything else is 0. So each L is a 110, 110, and there's also a 0 at the end. And then that's only 7 bits, so I'm going to put a 0 in front. And since there are 2 L's, there are going to be 2 of these bytes, if you will. So the binary representation of the word all takes 24 bits and 3 bytes to store this in a computer. And remember, a byte is 8 bits. So let's try the same thing with the word cake. So C, capital C, lowercase a, lowercase k, lowercase e. And so a capital C has the decimal number 67. The lowercase a has the decimal number 97. And the lowercase k is 107, and the lowercase e is 101. These are all the decimal values. So let's work on turning these into a binary. So I'll go 1, 2, 4, 8, 16, 32, and 64. And let's go C, the capital C first. And so that C is going to have a 64 in it for certain. And then there's 3 more to go to get to 67. So there's going to be a 2 and a 1, which means the rest of these things are going to be 0. So got that knocked out. Let's go to the A. So the lowercase a is 97. So I think there's definitely going to be a 64 in it. And if I take 64 and 32, that's 96. So there's going to be one of those in it. And then there are going to be all zeros remaining, and there's going to be a 1 at the end, and that would give me the 97. So that was doable. Let's go to the K. So the lowercase k is also going to start with a 1 and a 1, because that will give me a 96. And I need to go to 107, so I have 11 more to go. So that is going to be not going to be a 16. There's going to be an 8 in it. There's not going to be a 4. I need to get to 11. So there won't be a 4, but there will be a 2 and a 1, and that should give me the 11 more that I needed. So there is your K. And now let's try the E. Let's try the E. So the E is 101, so that's going to have a 64 and a 32 in it. And that's going to give me 96. So I have 5 more to go to get to 101. I have to add 5 more to get to the 101. So there's no 16, there's no 8, there is a 4, there is no 2, but there is a 1. And that should give me everything that I need. So cake can be encoded in binary, and if I'm going to turn everything into 8 bits or bytes. So cake is going to be 0, 1, 0, 0, 0, 0, 1, 1. There's the C. Then the A is going to be 0, 1, 1, 0, 0, 0, 0, 1. And then the K is 0, start with, 1, 1, 0, 1, 0, 1, 1. And then the E starts with a 0, because we need that extra bit. That's why we're doing that. And it's going to be 1, 1, 0, 0, 1, 0, 1. So this is going to take 32 bits and 4 bytes. So do me a favor. If you're watching this at home because you missed school for whatever reason, try these other two. Try up and try down. And I will do both of those, and then I will show you what the answer is.